And welcome to the Daily Space Weather. It's an exciting day for the Smash News Network least busted name in news. We've got coronal mass ejections. The likelihood of more remains very high. Are the coronal mass ejections headed toward Earth? We'll let you know here momentarily. Also, a Proton event, radio blackouts, and lots more coming at you with our Daily Space Weather. So you may see a little bit of activity happening up here as the Tamethoscope filament at least partially erupts. Is it still in place? And is the CME directed toward Earth? We've slowed this down for 4 hours. That's 1900. I'm sorry, 5 hours. That's 1900 through 0 hour, yesterday through midnight. And if you'd like to look at it a little bit closer, I think we can facilitate that. There you go, some plasma splashing back down and some plasma, well, you're probably wondering which way it's directed. So without further ado, let's talk about this model. It does not depict as much plasma as actually ejected, nor does it depict the fact that there were multiple CMEs that happened all around the same time. At least it does have it striking Earth. So that is about right with the trajectory. It is off to the north and west a little bit. Keep in mind, Earth is moving toward that. Let me just repeat that. We do have an Earth-directed coronal mass ejection. We're hoping to see the aurora here in Lehigh Valley, Pennsylvania. And if so, we will definitely document it on the Smash News Network least busted name in news. So back to that spectacular CME. That stands for coronal mass ejection, by the way, if you're a new viewer. And we'll talk about naming filaments later in the video. Yeah, naming filaments. We name them after living people. Look at the limb darkening that happens also. Right up here, you see the limb getting darker. That's a bunch of plasma absorbing some of the light coming from the sun. That's what we call a limb darkening event. And don't worry, we've got lots more imagery of the sun today. We've got more imagery than we typically show on the daily space weather videos. So congratulations on realizing the channel exists. Yeah, this is top-notch stuff right here. We're showing 15 frames per second here instead of the usual 30. Again, that's only 5 hours of data. Most of our custom movies are 24 hours of data. So let's take a look at sunspots here briefly. There is one new sunspot group to get named since yesterday. It's this little group right here. Not sure the number of that one. We do see some evolution happening down here. Some little bit of growth there. And some umbral migration happening up here as these umbrae start to separate from each other. And there was a long-duration M-class flare that did come from this group up here. That's 3229, I believe, is the number of that one. Let's take a look at the magnetic fields here. This is the SDO colorized magnetogram for yesterday plus today. It's an exciting day for space weather. So, super thrilled about that. There is the 24-hour SDO video. Also, we've got this. Check out this filament down here. That's the Lex Friedman. Let's go around the horn. There is the Lex Friedman filament. We've also got filaments named for Hillary Clinton and Kamala Harris over here. And we've got the Buzz Patterson filament, which we'll get to. Again, those are 24-hour videos. Again, by the way, folks, here is a 24-hour video of the southeastern limb. This is the Hillary Clinton filament. That's the Kamala Harris filament. And moving to the northeastern limb, up here we've got the Buzz Patterson filament, I believe is that one. Again, make sure you follow us on Twitter. You will see some other unrelated nonsense that has nothing to do with space weather, but we do put up the videos and other information like the hashtag Name That Filament challenge completed yesterday by Evan. Shout out to Evan for naming a couple of filaments there. So once again, here is the place that a lot of people will be looking at all day today on YouTube. Some will decide to hide in a bunker as a result of this. Let us know in the comments what you think the appropriate depth for your bunker is. So, by the way, if you enjoy the content, consider becoming a member of the Smash team. And we just put up a pretty important post last night because we had a little bit of an issue. So we were talking about bringing a guest on, and we didn't really get that guest on because we were having problems with connecting to Zoom on the PC that we use to make these videos. So we have decided to reschedule here. However, we have included a tidbit, not a tropical tidbit, a space weather tidbit. So if you aren't yet a member of the Smash team, head to smashomash.com/Smash team. If you're unwilling to pay us a few bucks per month to promote the content by becoming a silver or gold level Smash team member, just become a bronze level Smash team member. You do have to be logged in order to see the post we put up last night. The title of the post is Friday Night Fails. Just click the posts after you've logged in. You don't have to sign up for email alerts if you don't want to, although we do send out email alerts for things like tsunamis, space weather events, and other exciting stuff. Also, we do remind our viewers about our daily videos because we've noticed some issues when it comes to the people seeing notifications for the content. So thanks for leaving a comment. Mike Bordages, champion ski coach from the nation of Canada. All right, so here is our volcano rundown. Hey there, I'm back. Suwanosejima is erupting, producing a 6,000-foot ash plume. Popocatépetl is exploding, 22,000-foot ash plume over central Mexico. 14,000-foot ash plume over Guatemala from Santiaguito. Fuego in Guatemala also exploding. Flight level 160. That's a 16,000-foot ash plume. 20,000-foot ash plume over Ecuador from Sangay. 15,000-foot ash plume as Revenador explodes. And continuous ash emissions from Sabancaya are a good reminder to not pole vault the caldera. Next, looking at the last 90 days of seismic activity. Looks like it's been a little calmer than it was yesterday, as there is a 7 magnitude quake there showing up on the graph. And let's see what USGS has to say about the last 24 hours worth of earthquakes. So we're only going to report 5+ magnitudes, and there is a 5.0. That is near the Mariana Islands there. 5.0 magnitude there came in at 15:24 yesterday afternoon. That's 15:24 Universal Time. Also, Turkey continues to rock around the Syrian border there. We also had a 5.1 on the southern portion of the Mid-Atlantic Ridge. And a 5.0 near the Kamchatka Peninsula. Looks like it's very close to the Kamchatka Peninsula there, the volcanic peninsula of Russia. Also, we had a 5.1 at Japan and a 5.3 in central Turkey. And it's time to get back to space. So I think we've forgotten to put up some imagery here. I don't know how that happened. That's a rare occurrence. So let me just bring up some additional solar imagery for you here. We've got the 171 plus 131 angstroms wavelength, which will be spectacular, of course. And of course, we've got the 304 angstroms all by itself. So let's get those on screen. There we go. There's just ionized helium, 304 angstroms. Here is 131 plus 171 angstroms. And it's great at showing plasma aligning to magnetic fields. Don't worry, folks, we've got some close-ups of that M-class flare, the long-duration flare that's responsible for creating some polar radio blackouts that actually are continuing as we stream this video. So the 10.7 centimeter radial flux has increased as forecast yesterday. So it's now up to 164 solar flux units. The 10.7 centimeter radial flux, if you're new to the channel, is the most proportional data set to sunspot number. So there's a graph to help contextualize that. You can see this black line here is the 10.7 centimeter radial flux, and this red line is the sunspot number. Also, as forecast, we did see a little rise in the sunspot number, coming right up to 130 there. So 164 solar flux units is the 10.7 centimeter radial flux. And by the way, we can expect to see a CME impact mid to late day on February 26th, maybe early in the day on the 27th. I think more likely very late in the day on the 26th to early in the day 27th is when we can expect to see that CME impact. So right around midnight Universal Time, maybe a little bit after that on February 27th, you can expect to see a CME impact here on planet Earth. And we're hoping it's spectacular because, well, not because we're reckless, because we want to see the aurora in Pennsylvania. So it's quite unlikely, folks, that your power grid is going to shut down unless you are in some place besides a first world nation. And wherever you're viewing the videos, congratulations on realizing the content exists once again. So let's take a look at some earthly features here. This is the global geomagnetism, expressed as the planetary K index. Currently quite calm conditions here at 2.33 protons per cubic centimeter. Keep in mind there is a coronal hole high-speed stream on the way as well, so there could be interactions there. We'll talk about the coronal holes momentarily. First, the last 4 hours of Earth's magnetic moment from space. This imagery depicts magnetohydrodynamic pressure, or nanopascals. And this is part of the reason why we jokingly state that the Earth is croissant-shaped, because, well, Earth's magnetic moment from space is croissant-shaped. So, to a solar proton, Earth really is shaped like a croissant. Tell Neil deGrasse Tyson about it. Although the solid part really is an oblate spheroid. Next, looking at Earth's magnetic moment from the ground for the past 4 hours. Again, it's geomagnetically calm conditions here. This will still show you the most likely places to see the aurora, both borealis and australis, as well as the most likely places to see pipeline, railway, and power grid induction. Right now, things are chilling. So let's head out. Since these measurements have to be made closer to Earth, we'll head out to Lagrangian point 1, right about there, which is where the ACE and Discover make their real-time solar wind measurements. And we have been seeing an uptick here in the solar wind density, so it might be an early arrival of the coronal hole high-speed stream. Current conditions are 6.66 protons per cubic centimeter for the solar wind density, solar wind speed, just over 400 kilometers per second, showing up there at 407 kilometers per second. Here are our GOES magnetometers here. A little bit of flatlining there happening. And those are the measurements from the GOES 16 and GOES 18 from their geosynchronous near equatorial orbit. They're located at something like 23,000 miles of altitude. And let's take a look at the heliospheric current sheet next while we're looking at magnetic data. So here are the top view ecliptic plane field plot data. And we are moving right into the center of the south magnetic pole. This data is derived from magnetometers on stereo A, 51 ground-based magnetometers, and a magnetometer on stereo B. It's very definitive if you're going to forecast solar activity. The top view ecliptic plane field plot is quite good at it if you know how to read the data. Next, our line of sight plot. And welcome to the south magnetic pole. This will likely affect how things like coronal hole high-speed streams and coronal mass ejections affect planet Earth. And here is our line of sight coronal hole plot. So coronal hole super important to observe the solar polar field reversal process. To some of us, it's actually a more important process than the sunspot cycle itself, as there is some sort of a relationship between coronal holes and sunspots, obviously. Anyway, that's the current situation. Keep in mind when we see weak solar cycles, we see longer solar cycles. And when we see stronger solar cycles, we see shorter ones. That might be one to grow on. Let's take a look at the SDO imagery here for 211 angstroms. We've got a very well-defined transequatorial coronal hole here, and this one is going to provide some significant solar wind. So we've got some pretty serious space weather forecasts coming here. I think for folks that are out there trying to measure magnetohydrodynamic waves striking the Earth, I think you're going to have some great data coming in. So, yeah. Good stuff. That's the last 24 hours from SDO in 211 angstroms. We're going to get to sunspots here next. First, check out our latest design. There you go. Do the math and try not to suck at it. That is our latest design. We just put that one up yesterday, along with 2 others. You'll have to find out what those are yourself. And it's not just a plain boring space background, if you're wondering. It's actually something relevant to the channel that we've talked about many, many times before. And I don't want to sound like a broken record here, but Deneb, also known as Alpha Cygni, the brightest star in the constellation Cygnus, indeed the brightest intrinsically visible object from our entire solar system, probably the most important star in the galaxy. You could make the argument that Sagittarius A star may be more important. Anyway, we've included it in the imagery because reasons. We like facts. So right there, that actually is Deneb right there, the tail of the swan. And we encourage you to do the math and not suck at it. If you visit the links below the video, you will see our Redbubble shop. And if you click that link, you'll see the products in order of best selling. Go visit the link to see what products we uploaded yesterday besides that do the math design featuring the constellation Cygnus and Deneb. You'll also find links to the Hemp Lucid shop below the video if you're looking for CBDs or mushroom gummies or immune stacks or sleep stacks or other things like that. Check it out. Lots of different products there. And shout out to Hemp Lucid, perhaps our greatest affiliate/sponsor of all time on the channel. As we push the 6-year mark, there are big changes coming. Let's get to sunspots. So we'll have at least one more named sunspot group. I believe this one up here should get a name. That'll be 3238. And there may be some more small pores opening up here around the southeast and possibly even in the northeast. We'll show you high-res imagery of that before we get to our meteorology segment today. Here's the past 24 hours from SDO Continuum. So we do have some more active regions there in the east. We'll have one more new named sunspot group, at least this one right here. And let's move to energetic particles and solar flares since we've got some. Check it out. We got a Proton event associated with that long-duration M-class flare that generated the CME. Or that was associated with the CME, I guess I should say, because we don't really understand. It's a chicken or the egg sort of a thing when it comes to solar flares. Some people think that flares cause CMEs. Some people think CMEs cause flares. So anyway, that's the GOES proton flux there, and we're seeing some polar radial blackouts. And let's show our deabsorption regions prediction. So incoming X-rays, they do attenuate the D region of the ionosphere. And that's what causes your radio signal to go out into space instead of refracting back down to Earth. So this imagery will show you the most likely places to see absorption. And of course, we've got more of those features in the southern hemisphere. It is, after all, summer down there. And I think this is slowly subsiding here. We just barely got to the point where there is some attenuation there. Yeah. So that's what's going on. And of course, you can follow solar flares and their sort of instantaneous effects. Keep in mind, folks, solar flares don't, quote, get here, end quote. In other words, by the time the solar flare is measured, it's already here because it's photons. And if you don't understand the difference between photons and protons, let me explain this once again in very simple terms that even an elementary school student can understand, although some YouTube creators, some of whom have a lot more, like 100 times subscribers than we do, don't seem to understand this. So let me just explain it in a very simple way. Turn on a fan. You'll feel wind blowing on your face. That wind is kind of like a CME because the wind that you're feeling there is primarily because of nucleons, okay? It's protons. So, yeah, that wind, that's gas, all right? That's matter, regular old everyday matter, like what you're made of and what the air is made of. That's like a CME. Photons, turn the fan off and shine a flashlight in your face, okay? That is like a flare, okay? Flares are light in the form of X-rays, and CMEs are gas in the form of coronal material blasting out into space. Very different phenomenon, and don't get them confused, because here at the Smash News Network, least busted name in news, we like you to understand facts, not be utterly confused about space weather. So here is our X-ray flux, and this is the solar flare. It was an M3.73 class flare. Peak flux was at 2030 yesterday evening, Universal Time. And that is the event associated with that proton event. Some relativistic particles showed up, and they showed up quite promptly, actually, as we saw this spike really get going by 2200. So those particles showed up in only an hour and a half, moving at a significant percentage of light speed there. I won't do the math at the moment. Yes, 8 equals capital D. I guess I wrote that one myself. Anyway, here's the past 24 hours and 131 angstroms. And good stuff. Don't worry, we've also got 94 angstroms. Showing up a little bit better in that wavelength. Keep in mind, those are both species of ionized iron. And what's interesting about the different wavelengths is how differently those different species of ionized iron behave, despite having the same nucleons and just a different number of electrons in their shells. So here's a little close-up for you as the Tamitha Skov filament reorients. And shout out to Tamitha Skov, space weather woman. Check out her videos. She knows a lot more about what's going on with satellites and things like that than I do. And where we meet is sort of the bridge between cosmology and space/Earth weather. You could call that the money shot for the day, but don't worry, we've got a lot more. Including, of course, 131 angstroms. Now, the reason we use 94 and 131 angstroms to view solar flares is because they take 10 images per minute instead of only 2 images per minute like the other wavelengths. They are specifically formulated to view solar flare activity. We'll let that play through one more time. That is good stuff. Continuing on, we're always interested in what's going on overhead, so let's orient ourselves here for a minute before we talk about coronal mass ejections once more. So there's what's going on overhead, Lehigh Valley, Pennsylvania. Mercury and Saturn being chased by the sun across the early morning sky. If you're up before dawn, you might see the dim Mercury and the much, much brighter Saturn there, just south of the ecliptic at the moment. So that's what's going on overhead. If you want to create your own star chart, head to skyandtelescope.org. Here's our solar system forecast as we help orient our viewers. Remember, folks, CMEs that are headed in this direction, and in this direction, and in this direction are not going to allow you to see the aurora. However, CME is headed in this direction, and we've got one. Make it a lot more likely. So let's do a solar system forecast here. It's a lonely side of the solar system right now. No planets over here. Keep in mind this imagery is not to scale. Here's where things will be in 1 week. On the 4th of March, we will have a crescent waxing moon. And let's take a look at some coronagraphs. You're definitely going to see a lot of CMEs here. Keep in mind, some of these are happening at the same time at different locations. But this Tamitha Skov filament eruption is indeed featuring a significant Earth-directed component. So that's yesterday's imagery from George Mason University. We'll also show you today's limited imagery. There are some more frames, 40 more frames from today. As you see, CMEs continuing to happen, and you can expect more CMEs to happen as there are lots of filaments and increasing activity. So let's take a look at the view from stereo A, located right there. And we've started showing this imagery here because we kept telling people that stereo A was located at Lagrange 5, which would be like way over here. And it's only like 8 degrees off of the Earth or something at the moment. Anyway, that also shows you the Parker Solar Probe and the Bepi-Colombo and the Solar Orbiter. So we've actually paused this at 2253. All right, so from stereo A's perspective, Earth would be off on this line. And from Soho Lasco C3's perspective, Earth would be directly behind you because of its location at Lagrangian point 1. And so we pause this here at 2253 for stereo A and 2306 on the Soho Lasco C3. So if you look at this ejecta, there is a significant portion of ejecta there headed right down the Earth line. It is pretty much in line with the equatorial disk there, give or take a few degrees. And there you go. Some of that CME material is certainly headed toward Earth. It's pretty dense, so we're expecting a quite significant impact from that. As well as a coronal hole stream, we should be able to see a signal from both of those events. So let me just bring this back. We'll bring this back to first thing on the 23rd, on the 24th. Keep in mind, it's different instruments here, different spacecraft. We're going to let those sync up here after that plays through. Now we're going to start stereo A. Pay attention to the time and date stamps in the lower left, as again, those are not synced. So expecting a nice CME impact. Late night on the 27th. Or, well, late night on the 26th, early morning 27th. Anyway, here are our 24-hour videos. Several different events there. I'm not even sure how many. 1, 2, 3, 4, 5. There's like 6, 7, 8, at least 5 or 6 different CMEs all happening there. It's only the one that came from this area right here. It's the Tamethyscove filament. So perfectly named filament. And we are hoping we see lots of aurorae there. Most of the ejecta will miss Earth. But here's another view a little bit closer up. Some of that ejecta likely headed toward your doorstep. And even if you're viewing this video from space because you're an astronaut, do you have a doorstep? Headed toward your airlock. All right. So it's time to talk filaments. So let's head to the Cerro Tololo ground-based solar observatory here showing hydrogen alpha. And guess what? Good news. We thought the Tamethyscove right after we named it, we checked to see that it was still intact, and we noticed that it was ejecting. But here's the good news. The Tamethyscove filament is still there. So you got Tamethyscove, you got Lex Friedman, you've got Buzz Patterson. That's, I think, this one up here. And then you've got Hillary Clinton and Kamala Harris. If you'd like to name filaments, join us on Twitter. And by the way, this is what it looked like yesterday. We do it a little differently every time. This time, since we were naming 5 at once, we decided to name this one Lex Friedman because he's so prolific. So, a prominence seemed appropriate for that. Buzz Patterson, Tamethyscove, Kamala Harris, Hillary Clinton, and Lex Friedman. Anyway, once again, if you want to name filaments, join us on Twitter. Don't name ones that have already been named, and make sure you name them after living folks. So here at the Smash News Network, Least Busted Name of News, we're just doing this to create another little interesting way to make it a little easier to follow filaments and make it a little more interesting and amusing. So, again, you're invited by the Smash News Network, Least Busted Name of News, to name that filament. So the ones that aren't named yet, you are invited to join us over there on Twitter. And also on Twitter, you can find our pinned tweet. If you're still looking for free samples for mushroom gummies, they are still available. So we've had to change that around a little bit. There's a new link and a new image. If you click on that, you will find our free mushroom gummies giveaway. If you haven't tried them out, check them out. There are ones for stress, for focus, for sleep. There are also other products that have nothing to do with CBDs, so check them out. And maybe you'll love them as much as we do. So don't worry. We've got still additional imagery of the closest star for you. And thanks for stargazing with us. frankly, we're surprised that you found the channel. So here's the past 24 in 171 angstroms. I would also note that there is a plasma event that happens right here preceding the M-class flare and massive coronal mass ejection. So if you watch right here, you'll see some plasma reorient just before that happened. Was it related? There could be some magnetic looping happening around here that could have those things connected. It's tough to see because the SDO only has so much of a field of view. What's cool about 171 angstroms is that it shows you the potential field surface source lines. So all these magnetic loopy lines here, these are all showing you how the plasma is aligning to those magnetic fields. And of course, those lines are terminating at locations where potential field surface source locations are of course. So here is our last couple of hours in GOES 16 SUVI. And it looked like the Lex Friedman filament was getting unstable, but it's still chilling there. So that's a gravity-defying solar filament there, as it is not it's not conforming to gravity, as magnetic fields are suspending quite a bit of plasma, especially down there in the southwest. So that brings us to bonus features. So let's check and see what's going on with satellites. We've got some minor surface charging hazards there caused by low energy electrons in the central Pacific. Here's our GOES electron flux. And coming up off the floor here, no surprise to NOAA. Here's the forecast model. Expecting slightly higher levels here in the coming days. The green boxes are the forecast, the yellow diamonds are the observation. There's the one-year chart to put it in context. We're just in normal, fairly unremarkable levels here. We'll also show the layer of the ionosphere where it's measured, the F layer. That's located at about 300 kilometers of altitude. So let's show the vibrational frequency and the anomalygram. We've got some major low-frequency anomalies hanging out around South America. What this is showing is how fast portions of the ionosphere are vibrating. Keep in mind the gas up there is very diffuse. It's nothing like the gas down at surface level. It is basically space. There's a very low amount of gas up there. And this gives us insight into what's going on with the ionosphere because it's showing us the vibrational frequency of that material. Anyway, that imagery might not be too familiar with you, so we'll show you the anomalygram. That's the anomaly in megahertz from a 30-day median. You can see huge low-frequency anomalies at actually the North Pole as well as the South Pole and the South Atlantic anomaly, which is once again back over the South American continent, I think. Or is it? Has it moved again? Nope, I think it's still there. It looks like it's still over South America. It could be in the process of moving once again, folks. So if that does happen, we will report on it, as there are lots of fear-mongering, ridiculous channels on YouTube that are trying to convince their viewers that Earth's magnetic fields are about to reverse, which they might not be telling you behind the scenes that they don't even believe Earth's magnetic fields are going to reverse. Maybe they think their viewers are stupid. I don't know. Plenty of YouTube creators think that you, the viewer, are not particularly intelligent. Just so you know. Anyway, that's the anomalygram. There's the latest image, 1300 universal time ionogram and 1300 universal time anomalygram. We'll also show the total electron content. That is the free electrons between your GPS satellite and your GPS handset. That run is about 12.5 thousand miles, as that satellite has to communicate through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. So those free electrons can cause signals to refract. And this imagery will show you that. The total electron content forecast. That's the coupled thermosphere, ionosphere, plasmasphere, electrodynamics model. The universe is not electric. However, portions of it are, like the atmosphere. Going to deep space where it's relatively empty, it's certainly not electric. Anyway, that's our total electron content forecast. Again, that'll show you the most likely places to see GPS errors. No major surprises there. Things are looking quite normal here once again. We showed like 2 months of really anomalous total electron content forecasts on the channel. Were you watching back then? Anyway, here's our latest imagery from SDO, the latest intensitygram and colorized magnetogram. So this sunspot here ought to get a name today. Besides that, do we have any additional new sunspots rising or forming in the east? Nope. It's pretty clear at the moment. Anyway, there's your rock back showing the umbre and the fields. This one ought to get a name, although it has degraded, I think, since we did show prep. So anyway, it's time to bridge the gap between Earth and space. So we're going to do meteorology next. And please take a moment to visit the links below the video. As we're paid just this side of nothing to put out the content, and keep in mind we created smashomash.com in, I think it was January of 2019. Why? Because a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. No, you can certainly hire the Smash team. Just click the link. And don't forget to check out our post last night, Friday Night Fails. We sent out email alerts about it, because there's a very important video to watch that is linked there, and we're not going to share with YouTube viewers unless you sign up at the bronze level and log into smashomash.com/smashteam. Anyway, if you enjoy the content, press like, subscribe, share, comment, etc., yada, yada, yada. Congratulations on realizing the channel exists despite the pathetic, putrid, and disgusting censorship of youtube.com. We are trying to advance the science, and there are certain entities that are preventing that. All right, so we're looking at something we don't normally look at today. This is the upper level winds, the 10 hectopascal winds. So it's a low pressure wind currents there at a high altitude, and you can see how orderly that is in the southern hemisphere summer. Of course, a little bit of turbulence here toward the center of that, and of course it's very different in the northern hemisphere winter. So there are the 10 hectopascal winds for the northern hemisphere. Nullschool.net is just fantastic, and we've got a giant smiley face here that was unintentionally showing up, and it's a great time to be doing space weather and other such things. So anyway, it's a golden age right now for cosmology, astrophysics, heliophysics, and even geophysics in many ways, as a lot of nonsense is being thrown in the garbage so that we can move forward with the real science. Anyway, moving to meteorology, here are the jet streams of the eastern world. So a bit of chaos happening there around Australia and New Zealand, a strong low pressure there, right between the islands. Here are the surface winds of this side of the planet. Surface winds of the western world, depicted here. And we've got a powerful low here, which kicked up possibly even some tornadic activity. We saw a severe thunderstorm in the past about 10 hours. Anyway, those are the surface winds of the western world. Here are the jet streams of the west. Jet streams of the central world depicted here. And these are the surface winds. So those are the facts. Let's cover some more. This is what's going on in terms of water vapor over the Americas. This NASA GOES Interactive Weather Satellite Suite does show all of the water vapor. Check it out. Some rapid cloud nucleation happening down here. Whatever country that is. I don't know my South American countries to save my you-know-what. But anyway, that's what's happening in the Western world in terms of water vapor. It'll show you the dry air. It'll show you the moist air. It shows all the water vapor, or lack thereof. Next, our weather.gov map. If your location's lit, click your location. By the way, I discovered some non-hot air coming out of Colorado last night. More on that in a later video. If your location is lit, click your location on weather.gov. There are still blizzard warnings in Montana, California, and Nevada. Weather.gov. So here are some forecasts, starting out with the GFS 72-hour temperature anomaly in degrees Celsius. Like we said yesterday, some very warm temperatures coming to Missouri and Illinois. And also headed back to the mid-Atlantic states in about 4 days. So that's our GFS 72-hour temperature anomaly forecast in degrees Celsius. We will also show winds because we've got some wind advisories in West Texas. Check it out. There's going to be some severe winds in New Mexico and Texas. That is the GFS 72-hour pressure and wind. That's the pressure in millibars and wind at 10 meters. Going to have some very high winds there. Looks like pushing 50 miles an hour. 50-mile-per-hour sustained winds are pretty strong winds, folks. Let's move to our pressure and precipitation forecast. So here's pressure once again, but we've added precipitation. And there's some more ice coming. Yeah, some more ice storms. They're going to start out in Minnesota, and it's going to spread all the way to New Jersey. Yeah. Significant ice storms that are coming. So be prepared for those. That's your 72-hour GFS pressure and precipitation forecast. As heavy precipitation there coming to even Southern California. I heard something about a San Diego snow forecast. So yeah, some cold air penetrating very deep into the southern U.S. Even snowing on Baja California, it looks like. So let's look at our total accumulated snow depth change in inches. This is once again the same model. This is the GFS 72-hour total accumulated positive snow depth change. And yeah, look at that. Significant snow there on Baja, Mexico, like 6 inches in portions of Baja, Mexico. Never reported that before on the channel. Also some snow likely coming to the Lehigh Valley. Once again, that's your 72-hour GFS accumulated positive snow depth change forecast in inches. Dag. Some serious snow west of the Rockies. So we're going to show the Euro forecast as well. So there's the GFS for the next 3 days of new snow. And there is the Euro for the next 3 days of new snow. GFS, Euro. GFS, Euro. And let's move on. Here's our lightning mapper. We show it daily. Severe thunderstorm there in the north central Atlantic. Looks like it will miss the Azores to the north. Here's our real-time lightning map. And are we still getting active strikes there in the North Atlantic? Anyway, next time you hear thunder, check it out, lightningmaps.org. It could save your you-know-what. It might tell you whether you should wait in the car or just head into the grocery store. I've used it for that purpose already. We have had some fairly recent strikes here just northeast of Nashville. Yeah, Nashville. Pronounce it correctly. Nashville, Tennessee. All right, closing things out here. Here's your U.S. Doppler radar map. Looks like it's going to snow in Pennsylvania if it's not already. Hey, Smash Staff, is it snowing yet? Dag! So we love snow here. I don't mind the inconvenience. I don't intend to ever graduate from being a fan of snow. Did you know that I'm a professional driver in addition to a cyclist? Here is your U.S. clouds and fog view. 3.9 nanometer infrared radiation. And look at this jet of moisture coming in from the Pacific. That is berserk. The Pacific this low off the coast of California is just pumping the moisture into California and Nevada with significant results. You'll be able to see it on the water vapor as well. That's the water vapor map. And let's close this thing out with a recap. So there's your recap, U.S. Doppler radar. That shows, those are ground-based systems that show vertical motion of water droplets and ice crystals. Here is clouds and fog, 3.9 nanometer infrared radiation. Shows that it's too dark over the western portion of the country to use the visible, so we use this to show you clouds and fog, and there's water vapor. That should help clarify things. You can see some wild pressure gradients happening here in the Gulf. Indeed, those are gravity waves, if you prefer to use that term. I kind of try to avoid it. Anyway, in any case, thanks for tuning into the Smash News Network, least busted name in news. We remain surprised that you've ever found the channel in the first place. So we'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.